Lection number 8, development of recipes for new product from vegetable raw materials. Plan of the lecture, raw materials and vegetable raw materials, calculation of energy value, identify the disadvantages and effectiveness of new plant products. I would like to start our lecture with a project of our scientist, Professor Chomanov. His project was the development of high-tech technologies for deep processing of agricultural raw materials in order to expand the range and output of finished products from a unit of raw materials, as well as reduce the share of waste in the production of products. Kazakhstan is one of the largest producing countries of agricultural raw materials in the world. The President of Kazakhstan, Kassym-Jomart Tokayev, in this message to the people of the Republic of Kazakhstan, constructive public dialogue, the basis of stability and prosperity in Kazakhstan, paid special attention to the agro-industrial complex. The message says that it is necessary to move away from a raw materials orientation of the export of agriculture products, which has reached 70%, while processing enterprises are loaded with only 40%. Also, at an expanded government meeting held in January 24, 2020, the head of state also noted that the share of processing in the total agro-industrial complex is only a third. The efficiency of agriculture depends on agro-processing, and it creates demand for agriculture products and increased its added value. Kazakhstan has a huge raw materials base for processing as well as for deep processing of crop and livestock raw materials. A strategically important state task for the solution of which a program has been developed is the need to increase the depth of processing of agricultural materials, the involvement of secondary resources in the economic circulation, which will increase the yield of finished products per unit of processed raw materials and reduce the share of waste in the production of agricultural products. The idea of scientists of the program is to develop science-intensive technologies for deep processing of agricultural materials in order to expand the range and yield of finished products from a unit of raw materials, as well as reduce the share of waste in production, maximize the use of raw materials, potential of secondary products of poultry, slaughter, for example, chicken legs, heads, meat, and bone residue, cattle, bile, internal fat, intestinal raw materials, blood, category, second byproducts, bone, skin trimmings, secondary products of the sugar industry. We have here sugar beet pomace, waste of melons and gourd processing, peel, seeds, walnut in the production of food and animal feed. As part of implementation of the scientific and technical program and in order to accelerate the development of high-tech technologies, it is planned to create demonstration sites with modular production lines for working out of the modes of technological process of production, developing pilot batches of products and preparing recommendation for their development by production. Okay, we will talk later about raw materials and vegetable raw materials. Raw materials are substances and products that manufactured and processed used to create finished goods. Food manufacturing companies will purchase raw materials to make foods for human consumption. Fruits and vegetables are commonly produced in farm field, trees, and greenhouses. They are sold directly for consumption and can also be used as ingredients for dishes. Fruits come from flowering plants and often sweet. These raw materials include apples, berries, bananas, and pineapples. Vegetables are usually grown in fields and are defined as many plants that is used for food. This entails celery, carrots, potatoes, and literature. Despite their differences, fruit and vegetable have high amounts of vitamins and minerals that are beneficial for the human body. Here in this table, we will talk about the food industries, their raw materials and process. For example, in meat processing and preserving, we have materials beef, lamb, pork, poultry, and the storage requirements is cold stores. Processing techniques is slaughtering, cutting up, boning, comminuting, cooking. Preserving techniques is preserving techniques are salting, smoking, refrigeration, deep freezing, sterilization, and the packaging of finished products is loose or in cans or cardboard. And in fish processing, all types of fish we have as materials and cold stores or salted loose or in barrels. Process techniques, heating, cutting, filtering, filleting, and cooking. Preserving techniques are deep freezing, drying, smoking, sterilization, and for packaging is loose in refrigerated containers or in cans. And fruit and vegetable preserving. As the materials, we have fresh fruit and vegetables. Storage requirements are processed immediately. Fruits may be stabilized with sulfur dioxide, and processing techniques are blanching or cooking, grinding, vacuum concentration of the juice, and the preserving techniques are sterilization, pasteurization, drying, dehydration, um, okay, and freeze drying. Packaging or finished products are bags, cans, or glass or plastic bottles. Here you can be PET bottles. And milling, for example, materials, grains, and storage requirements. Silos may be uh, fumigated in storage. Processing techniques are grinding, sifting, milling, rolling. Preserving techniques, drying, cooking, or baking. Packaging of finished products, silos conveyed pneumatically. Sacks or bags to other process or boxed for retail trade. And other parts, so for example, we have baking industry, biscuit making is confectionery, yeah. Sugar processing and refining. Here we have sugar beet and sugar cane, and chocolate making and confectionery, distilling and the manufacture of other beverages, for example, fruit, grain, carbonated water, milk and milk product processing. For example, at the materials, we have milk, sugar, and other constituents. Processing of oils and fats, for example, groundnuts, olives, dates, and other and vegetable fats, plant and vegetable fats. Here you can find storage requirements, processing techniques, preserving techniques, and the packaging of the finished products. For example, processing of oil, so we can package the oils to the bottles, packets, and cans. Okay, calculation of the energy, uh, Water system is used in the food industry to determine the total calorific value of food or by employing the 4, 9, and 4 method. This system applies energy conversion factors to the macronutrients and the carbohydrates, fat, protein, and fiber. The average values of energy are expressed as the number of calories per 1 gram of the macronutrient. The Atwater general factor system includes energy value of 4 kilocalorie per gram for protein, 4 kilocalorie per gram for carbohydrates, and 9 kilocalorie per gram for fat. Alcohol is also technically considered a macronutrient and contains 7 kilocalories per gram. For instance, if you have a food that contains 20 gram protein, you might multiply 20 by 4 to give 80 calories supplied by protein in that food. A more extensive general factor system has been derived to include organic acids used in food preservation at 3 kilocalorie per gram and polyols at 2.5 kilocalorie per gram. These figures were originally determined by using a Bohm calorimeter and measuring the heat of food composition and the resulting amount of energy the food produces. Here, the next practical consideration. There are a number of shortfalls when using the Atwater system to determine the total calorific value of the food. The energy conversion factors estimates and therefore likely to be associated with some inaccuracy when compared to the direct assessment method Bohm calorimetry. The energy conversion factors for macronutrients as a whole are not clear. Protein, the calorie content of individual amino acids were found to be different when calculated by correction of heat combustion. Here we have the table. However, the protein conversion factor of 4 calories per gram was derived as an average for the energy yield of all amino acids. This means that if a good food contains a large amount of the amino acids phenylalanine, which yields 6.7 kilocalorie per gram, a relatively high energy value compared to other amino acids, then the overall energy value of the food may be higher than what is derived by a calculation using the protein conversion factor. The table below shows the heat of the combustion produced by each amino acid used as the energy conversion factor. Here we have amino acids and the meaning of the heat of combustion for kilocalorie per gram. The highest one here we have phenylalanine, 6.7. Then we have the other amino acids, isoleucine, lysines, and tryptophan. We have 6.5, and arginine 5.1, and ornithine 5.5, and the other, tyrosine we have 5.8, and valine 5.9. Carbohydrates. The assumption based on carbohydrates are even more problematic. Firstly, the conversion factor doesn't distinguish between sugar, starch, and dietary fiber. For example, monosaccharides have combustion heats of around 3.75 kilocalorie per gram. These saccharides 3.95 kilocalorie per gram, and the polysaccharides 4.15 kilocalorie per gram. There are also sugar alcohols to consider, organic compounds that are derived from sugar, also known as polyols, all with a varying energy conversion factor. For example, xylitol provides 2.5 kilocalorie per gram, whereas glycerol provides 4.3 kilocalorie per gram. and erythritol is a 0 kilocalorie program. By way of example, if a food was predominantly made up of monosaccharides, the energy conversion factor of 4 kilocalorie per gram may result in an overestimation of overall calories. Secondly, the add-water method doesn't account for variance in fiber and the resultant calories. Fiber can be particularly degraded and absorbed in the large intestine and is assumed to be 70% fermentable, thereby providing some metabolistic energy. The extent of this degradation depends on the individual and the source of fiber. There is currently no clear data to provide guidance to how to factor in the influence of fiber. Also, 2 kilocalorie per gram is typically used as the conversion factor for fiber with the food industry. Okay. Next is fat. Fatty acids also differ in their heat of combustion. However, the difference is relatively small. Long-chain triglycerides have a value of 9 kilocalorie per gram, whereas medium-chain triglycerides have a value of 8.3 kilocalorie per gram, and the salatrims, which are used as reduced calorie fat substitutes, have a value of 6 kilocalorie per gram. To identify the disadvantages and the effectiveness of new plant products, plants are very useful to us, and we got most of our food from plants. Everybody needs food to stay alive. Yeah, food is one of our basic needs. It gives us the energy to work. Most of our food comes from plants. Plants give us many things. Food, for example, we get from plants. Plants, vegetables, fruits, cereals, and pulses. Plants also give us coffee, tea, sugar, oil, and spices. We got food from different parts of plants. We eat roots, leaves, stem, flowers, and fruits of plants. Vegetables, for example, some vegetables are available throughout the year. Some vegetables are available in one season only. So we would eat roots, leaves, stem, and the flowers of some plants are vegetable. Roots, there are beetroot, radish, carrot, and turnip. Leaves, spinach, lettuce, and cabbage are some of the leaves that we eat as vegetables. Stems, potato, and ginger are some of the stem and flower, broccoli, and cauliflower are some of the flowers that we eat as a vegetable. Okay, for example, fruits. We have fruits of many kinds. Some fruits are juicy and fleshy. Um, for example, orange, mango, apple, grapes, and so on. Fruits keep us healthy and strong. We should eat plenty of fruits daily. Growing children should eat plenty of seasonal fruits. Cereals, we get cereals from plants. Cereals are grains that can be eaten. Rice, wheat, maize, barley, and the jowar are some of the cereals that we eat. Okay, and plants give us coffee and the tea. To drink coffee is made from the seeds or coffee plants. Tea is made from the leaves of the tea plant. Here we can find the references of this lecture, and thank you for your attention.